is based on the principle of divide and conquer. So QuickSort uses the technique known as the divide and conquer technique. Divide and conquer means whatsoever data set is given to you, you are supposed to perform certain operations in such a way that after one operation your list will be divided into two sublists, and in that sublist how that will appear in that sublist. Suppose this, if I consider this as a single sublist, after certain operation when you perform on that, then there will be one central element. We refer to this as a pivot element. Pivot element is a special element which can be chosen as random element. So you can choose any element as a pivot element. With respect to this element, we'll try to sort our list. So there is no hard and fast rule that how do we choose a particular pivot element. Pivot element, either you can take first one, you can take any element. So whatsoever you do, according to that your sorting will proceed, right? So if whatever element we have taken as the pivot element, that element will be kept here. If I say that I have chosen out of this, I have taken this 44 as my pivot element. So when I am done with certain operation, what are those operations? I'll talk about it. After certain steps, what will happen? All the elements which are towards the left of your pivot element, they will be less than 44. Right? So all the elements which are there in the sublist 1, let us name it as sublist 1. So this sublist 1 will contain all the elements which are less, and the second sublist will have all elements which are greater than the pivot element, which we have, as of now we have taken as 44. Right? So this is how it will happen. Now there is another important thing. So when I say that all the elements which are towards the left of this pivot element, they will be less than 44, it does not imply, it does not mean that the elements which are there in the sublist 1, they will be in the sorted order. It is not compulsory. So in most of the cases, they will not be sorted. If one of the case may, like one of the very few cases you can see that they are automatically sorted, that may happen. But do not assume that all the elements which are there in sublist 1 and which are less than that of your pivot element, they will be automatically sorted. No, they will not be sorted. Similarly, here also in the sublist 2, all the elements which are greater than 44, they will be greater than 44, but there is no guarantee that they will be in the sorted manner. Like in themselves, they will not be sorted, but this thing is for sure that after those operations, they will be all will be greater than that of 44. That is for sure. The only thing which you are not sure about is that whether they are sorted in themselves or not. So what we need to do is, means after the first step, your list will be divided into sublist 1 and 2. And after some time, so now you have got sublist 1 and sublist 2. The same operation will be performed on this sublist 1. The same operation will be performed on sublist 2. There also you will choose one pivot element. In this also you will choose one pivot element, and same procedure will be followed. All the elements like before 44, obviously this sublist is 40 less than 44, that will remain same. But out of those elements, left hand side elements of this pivot will be less than this and they will be greater than this, and obviously they will be less than 44, that is for sure, because we are dividing your sublist into the smaller parts. So we will keep on doing this operation till the time we have a case where we just got two elements in a sublist which are just swapped with one another. So we will stop at that case. Otherwise, we will keep on dividing our sublist into smaller sublists and so on, and we will keep on sorting them. Similarly, this thing will happen in the sublist 2 also, and we'll keep on doing this operation till the time all those small parts become sorted in themselves. Then we will combine them all together. Fine. This is a basic fundamental rule. How do we use the QuickSort? So that is why it is called as a divide and conquer algorithm. It uses divide and conquer algorithm. So you are supposed to do only example for that. Like we need to just know the fundamental rule of it. We're not doing the algorithm for it. Fine. So is the basic fundament clear to you? Is it clear? If it is clear, then I will start discussing this example. Then it will make things more clear for you. Okay. So now let's see how QuickSort works. In this case, I have taken one data set with me, which contains 44, 33, 11, 55, 77, 90, 40, 60, 99, 22, 88, and 66. This is some random set of example set of elements which are given to me. In this case, I have taken 44 as my pivot element. Right. So I have taken this as a pivot element. Right. So the first case that you have to do is the very first step that you are supposed to do is that you will traverse this list from right to left. So the first step is you will choose a pivot element. After that, you will traverse this list from right to left. Traverse means you will start comparing 44 with the elements, but starting from the end of the list. So we will go this way. Fine. So I will start comparing 44 with that of the other elements, and I will stop when I will find any element which is greater than that of the, sorry, less than that of 44. Fine. And then I will perform swap on it. I'm repeating it again. The very first step is you will find out the pivot element, then you will start comparing this pivot element with that of the elements toward from the end to towards this side, right? From right to left, traversal will happen. And as in when you come across any element which is less than that of the pivot element, you will do the swap operation. So what is the purpose of using that swap? Because the ultimate goal of this quick sort is that whatever element is smaller than that of the pivot element, it should be towards the left. So that is what we are doing by performing this operation. So we'll start the comparison. Compare 44 from right to left and swap with element if less than 44. Fine. So now I will compare 44 with that of 66. It is 66 is greater. Then I will compare with 88. Again, it is greater than that of your 44 element. Now, when I compare with the third last element, that is 22, you know 22 is less than that of 44. So what we will do, because 44 is greater than that of 22, it means 22 is supposed to be towards the left. So what we will do, we will do the swap. So it will become, the list will now become 22, 33, 11, 55, 77, 90, 40, 60, 99, and in place of 22 now we will keep 44, 88 and 66. And this is our this is again. Pivot element will not change. Pivot element will not change till the time it is at its required or at its designated place. Right? So what is the designated place of a pivot element? Designated place of the pivot element is that all the elements towards its right are greater than it and all the elements towards the left of it are less than it. Because we have not reached at that stage, so we will continue with the operation. Fine. So here you can see is all the elements toward the right have come a little bit more than that of. Now the next thing is when your pivot element is toward this side, now what we are supposed to do, please listen it very carefully. Now we will compare in the reverse order. Reverse order means if your pivot element is toward this side, we'll start comparing from this side. If it is towards the right, we'll start comparing from the left side. So compare left to right. and swap if any element is greater than 44. So when I will swap that greater element, I will move that towards the right. So I will compare 44 with that of second element now. I will not compare it with this one because it is already at its required place. Right? So 44 will be compared 43, right? Then you will compare it with that 11. 11 is smaller, but we are supposed to stop when we find any element which is greater than 44. So when we will compare 44 with that of 55, 55 is greater than that of 44. So we will do the swap operation. So now it will become 22, 33, 11, 44, 77, 90, 40, 60, 99 and 55, 88 and 66. Right? So this is 55. Now you can see that all the elements now which are towards the left of it, they are increasing, and they are all less than that of 44. Now tell me what is the next from where I do the comparison, which left to right or right to left? Tell me, how do I compare 44 now with rest of the elements, left to right or right to left? Yes, it will be right to left. So when I start comparing, then I compare right to left, and when I will stop, I will only swap when I will come across any element which is less than that of 44. So which element is less than that of 44? Even if I compare with them, they are already greater than that. 99 is greater, 60 is greater, 40 is smaller. So we will stop here and we will swap it. So now it will become 40, 77, 90, 44, 60, 99, 55, 88 and 66. So 40 and 44. This is where we are. This is our pivot element again. So we have done right to left. Now the next step is we are supposed to do left to right. Start comparing left to right, and we will swap 44 with that of 77 because this is the element which is greater than that of 44. So order will be 22, 33, 11, 40. This will be swapped. So it will become 44, 70, 44, 90, 77, 60, 99, 55, 88 and 66. This is our pivot element, and other element which we have swapped is 77. Right. So now there is just a one again. We need to do it once again, right? We need to do it once again. Why so? Because we are still not sure that is there any other element which is towards the right and greater than that of 44. So we will do one more right to left. We will do one more right to left traversal just to cross check that whether we are at a particular stage where the pivot element is there at the center in the sense that all the elements towards the right are greater and all the elements towards the left are smaller. So when we'll do the right to left operation again, you will get to know that there is just one single element which we have not scanned till now. Even if when we scan it, even if when we scan it, we'll get to know that this 90 is greater than that of 44. And so then we will stop this comparison operation. After we are done with it, you will very well see that all the elements which are towards the left, they are less than 44, and all the elements which are greater than that of 44, they are towards the right of 44. And so this way, after certain operations, you will be able to keep this 44 element at its required place. So when we will start doing the comparison between these two elements, right? So in that case, we will not be considering 44 because after doing these comparisons, 44 is there at its required place. When we will do the same function again, we will consider only 22 to 40 elements, right? And in this case, we will consider elements from 90 to 66. So this is how your QuickSort works. Similarly, we can keep on sorting the sublist, and ultimately we'll get one like sorted list in which all the elements will be there at their required places, right? This is how QuickSort works. In case any